as I told before, plugins are organized in a tree. Every placeholder has its plugin tree. And then this list for each plugin in this list, we retrieve the context, just like a get context data method, and a template, like get template names in the views. And these two information, the template and the context, are used by simply rendering with this code, which is just render to string or template render according to the situation. It heavily resembles the usual views, how the class-based views works, and it's not really a chance, even if predates the advent of class-based views. And it also has context processors and plugin processor, which are basically middleware. They are not used in the request response cycle because the plugin is rendered in isolation. It takes the request, but it doesn't return a response because it just pasted into the template. But yeah, the function of plugin processor is almost the same as process response in middleware. All these steps are very heavy in terms of ORM and database queries. So we cache as much as possible. Either locally on objects, you will see a lot of dash placeholder cache, whatever, dash placeholder plugin cache, etc. in most of these functions because you don't want to hit the database too much. And also everything, placeholder page, whatever is cached on by using the Django cache. Any question for this first part?
Give me a second.
Yeah.
So actually a quick question first on part 0. If the node list is completely hijacked in that way, is there actually a need to be adding CMS toolbar to the template? Could that stuff just be inserted into rendering further up?
Sorry.
Could that be sort of wrapped into the rendering process rather than part of the templating process?
Well, in fact, there is integrating Django debug toolbar sometimes is a bit tricky, but it worked. I mean, you just have to be careful during the setup, and we try to play nicely with it, and so you should not encounter any issue with Django debug toolbar. Especially lately, it's also used in a test suite, so we want to be sure that everything works okay.
So I think it's probably fair to say that of third-party packages which use and abuse the admin, Django CMS is pretty much right up there in the maximum level of use and abuse that happens. So, you've just heard Dora, we're discussing various ideas of what we could do with the admin, things that we don't like, things that we'd like to rewrite, things that we would want to add. So kind of two related questions here. One, what is your wish list of feature points or extension points that would make the admin more powerful for Django CMS? Or things that you've already written that we should include for everybody? Or kind of on the other side, if we were to rewrite change list, would that completely cause you a problem, or would it be irrelevant to you? If we were to rewrite model admin, what would happen? So what are your thoughts on that?
Okay, so I think that talking with other people working with Django CMS, the top wish list is having a REST-based admin. Django CMS uses a lot the front-end admin we've seen before, which is still just monkey patching the HTML that the admin returns. So it's not the cleanest way to work. We managed to achieve a nice improvement, the speed improvement in 3.2, but it's still monkey patching or rather. So moving to a REST-based admin would be a huge boost because it will allow to create REST-based interface for Django CMS, but also for other applications. This is, I think this is it would be a pain to rewrite the old admin code of Django CMS for a new REST-based admin, but I think it's the
It would make it a nicer code base.
Sorry?
Yeah, it would make it a nicer code base.
Yeah.
So if we were thinking, I'm thinking from a development point of view here, where we could take the Django admin, and this is more my personal side of things. We could rewrite model admin so it used individual views rather than methods on the model admin that don't work very well, and so there'd be a big configuration change that could happen there without any actual functional change to start with, and then we've got a better structural basis to add features to, such as content negotiation support or something, to allow it to work in different ways, allow the same views to work in different ways depending on what you throw at them. So obviously, that feature at the end would be super useful for you if we were to rewrite model admins, change list view, and that kind of thing as those extension points that you use, or can we throw those away and it won't hurt?
Well, for the changes, we wrote basically an entirely new change list, because let's see if I can go quickly back to the,
basically, you're not actually using that as an extension point anyway.
You're not using the basic change list, because our change list is a tree, the tree of pages. So let me quickly browse through the. Okay, is this one?
Okay.
And
that looks like you also have your own front end for the admin as well.
Yes.
Is that CSS only, or is that an HTML template?
Heavily template customizing for this.
Heavily customized or rewritten? Because that makes a big difference to backwards compatibility, right?
Customized.
Okay.
Not rewritten.
Fun.
Not fun.
Not fun. Okay. There's a couple more general questions, but they're not specifically about the admin, so I'll cover those at the end.
Okay. Okay. And the admin is the good guy, and the bad one is the ORM. It's actually not the ORM. The bad guy is how Django CMS uses the ORM, which is, bad or badass, depending on the interpretation. So the basic models are these 4 models. Probably they're not very clear from a distance, but you have title here. Well, you have page here, you have title, and then the placeholder and the plugin. These are the 4 models I've shown before. There are other models around, but they're not that interesting. So, as I said before, page and plugin, in this case plugin model, are basically tree structures. And we use MPTT or treebird, according to the Django CMS version, to handle all the tree intricacies. And so the interface is quite simple at that stage. As you've seen before, this is the page tree. So we have all the pages nested one to another. And this is how the plugin tree is rendered. Every placeholder has its own tree of plugins. So we can go into much details about how Django CMS uses the ORM, but I think the most interesting things to see are the page publication process and the plugin polymorphism. Django CMS keeps 2 versions of each content, basically. The draft and the live of each page, and for each language. So you end up having, for any logical page, you have 2 model instances of the page model, and 2 copy of each title in each language. And each copy, each version, live and draft, contains copy of placeholders, and which contains plugins. So in a scheme like this. I'm very bad at drawing, but hopefully it's clear enough. So you have the page, which contains everything. Then you have the titles in the 2 languages, and then inside the pages, you have the placeholders. These are just 2 random placeholders with a bunch of plugin with the language attached. So when you want to publish a page, what you do is discard the old title and plugins and copy the title and the plugins from the draft version to the live one. So what it does is selecting this blue objects and copy them into a new page. And in the process, we are going to copy the placeholder too, obviously. So let's see a bit of the code is heavily edited because code is quite lengthy, but I try to explain the most important parts. Then we can go into details if you want during the questions. So the first thing is getting or creating the new page, obviously. This is in the case you have no public page, live page before. Otherwise, you just recycle the existing one. Then you copy all the attributes from the draft version to the live version, and especially with a special care for this one, which are the attributes which link together the public and the draft, because you will want to go back and forth from the 2 versions of the same page in a very easy way. And then you save, and this save will eventually adapt all the tree information on the page. Now you have the live version of the page up to date with the draft one, and then you copy almost in the same way. You copy the titles attached to the page, eventually filter on the language. For efficiency, we just recycle the old titles if they are available. So in this way, we assign to the old title the new primary key, and we assign the page. And again, we provide the information to go back and forth between the live and the draft version of the title. And then the copy of the content, okay? And this is just getting the plugins in each placeholder, and then create placeholders on the live version if needed, and then copy the plugins, which brings us to the plugin polymorphism, which I call poor man polymorphism because it was conceived way before there was a generic Django application to handle polymorphism. CMS plugin model is unique in the models of Django CMS, as it's the only CMS model that you are supposed to extend, and actually you have to extend it to make useful things in the plugins. And it's just, apparently it's just another model which you extend. But due to the way inheritance is handled in Django, this operation, both way of doing the inheritance, either by using an abstract base class in CMS plugin or multi-table inheritance, would be very heavy in terms of database load, because the CMS does a lot of listing of plugins in a placeholder and reorder plugins, etc., etc. So how Django CMS solved this problem, because even if most of these issues are related to the editing phase, the listing of plugins is done when you render a plugin. And so we implemented a polymorphism. So only the base class, which is a concrete class, is used, and CMS plugin is used during the most complex operation, like building list of plugins, copy plugins, reorder plugins. In this way, we only hit one table, we have no join, we have no whatever, and we try to make things as much fast as possible. And we'll see a couple of examples of how the polymorphism is handled, then we can see others later. The first function is downcast plugin, which we encountered in the previous section about the rendering of the plugins.